Hello all. I hope uh, you can see my screen. So today it is our second day of live coding. So in this session, we will do this NLP assignment. Okay. So in this assignment, we have some questions, and we will try to code those questions. So this is the assignment, and it is based on NLP only. So what are the contents here? We have dataset. So we will describe about the dataset. Then we will import libraries. After importing the libraries, we will import dataset. Then we will do some pre-processing on our data. After that, we will be building LSTM model. After building that LSTM model, we will generate text with that LSTM network. Then we do data post processing, and we try to build a larger LSTM network. And then we will be generating text. Means we will do inference. Okay, so this is the complete workflow we will follow. So we will use a GPU for this. So let's connect. Okay, so it is connected now. So first we went through the data set description. So here we are use going to use the Adventures of Sherlock Holmes as the data set. So this is one famous book. So we will take this book as our data set. Then import libraries. So first of all, we try to set TensorFlow version 2.x. Okay, as a TensorFlow version. Uh, and if it is not possible to set that version, then we will ignore errors. So we will write try, then percentage TensorFlow underscore version 2.x. Except exceptions. If exceptions occur, then so let's run this cell. Okay. So it is done now. Okay. One second. Just a second. Then import sequential model. Okay. Uh, from TensorFlow, and we will import some layers like dense layer, dropout layer, and LSTM from TensorFlow. After that, we will do a model checkpoint from TensorFlow. Uh, and then we will import two categorical from TensorFlow. So this two categorical is to do one hot encoding of target variable. Okay. So let's import sequential from TensorFlow. So we will write from TensorFlow dot keras dot models. Uh, what we need to import sequential. Okay, so this is the first import. Then we will from TensorFlow layers, we will import dense layer, dropout layer, and LSTM layer. So from TensorFlow dot keras dot layers, import dense, then dropout, and in the last LSTM layers. Okay, so after that we will import model checkpoint. So so we do from TensorFlow dot keras dot call convex. Import from callbacks what we will import model check point. Okay, and in the last from tensor flow dot keras dot utils import to categorical. So we will import to categorical. So let's run this. Okay, so this spelling is wrong. TEL as what tensor flow. So let's run that. So it's run now. Now we will import some libraries which is required in our flow. So what we will import? We will import NumPy. Import NumPy as NP. Then we need to import URL lib. So this library URL lib is required to read the data from the URL. So we will do import URL lib. Okay, and then we need to import system library. So import sys. Okay, we will run this. After that we will import dataset. So to import our dataset we will use url lib dot request dot url open, and then we will provide this url. So this is the url which is available on my github repo. So we will use it. So url lib dot request dot url open, and then this data we will store in response variable. So just run this. Okay, so now come our first part. Okay, so 1 second. Great. So now let's start. We need to complete the function to read from the response object. So what we do, we uh, we do response dot read. Okay, and dot decode UTF-8. Then what we do, we convert this complete data into lowercase. So raw text dot lower will come in the raw text, and then we will return raw text. Okay, so we will run this code. So if we will check now, we will run this function read text with response. And what is response? It is the variable which has this data here. Okay, so we will run this and store this in raw text. I hope it is clear till now. Now data pre-processing. Now, first of all, we will see the first hundred, oh sorry, first thousand characters in our data. So we use print raw text and then 2000. So this is the data to Sherlock Holmes. She is always the woman. I have seldom heard him mention her under any name. In his eyes, she eclipses, and like this data is there, and all data is converted to lowercase. Now, what they are doing from this data, okay, for raw text, they are converting it into set and then converting it into list, and that is also sorted. So let's run this code. First 20 character. Okay, so this is the output now. So what we do, we take unique characters, okay, not words, like characters we take from raw text. Set help us in taking the unique characters only. Then we create the list of those unique characters, and then we, with the help of sorted, we sort that list and save in characters. So these are the unique characters in our data. I think we are developing character level model, so that's why. Okay, okay. Now come our second question. It is create mapping of unique characters to integers. So till now we have extracted characters from our data, and now we will create mapping of unique characters to integer. For every characters we will assign an integer. Okay, so for that we need to put code here. Okay, so we will use dict. Okay, and what we do, c comma I, okay, for I comma c in, we use enumerate function of Python for enumerate characters. Okay, so like this we will run this code. So now what we do, we created dictionary of c comma I for I comma c in enumerate characters. So what enumerate do, for every character uh, it assign an index value I. So that will be the integer for each character. Okay, so Now we will run this function character mapping on characters and store the output into character to int. Let's run this character to int. Okay, so you can see that for every character, like backslash and zero is there, for the space one is there, apostrophe uh, two is there, and percent three is there, and like this for a character integer value is assigned. So if you see total 61 unique characters are there. If we will see, it is starting from 0. So there are total 62 unique characters in our data. Okay, so we are developing LSTM for character events. Okay, let's go to next. Now, how many characters are there? So we use n characters equal to len raw text, and how how much vocab is there? So length of characters. So characters and raw text. So what is the meaning of vocab? Means unique occurrences of word. Okay, so it will be 62, and total characters means characters can be repeated. So those will be 5 lakhs or 61,625. So let's run. Okay, it is the same. Okay, now jump to next question. Here, create input and output variables. So we need to create input variables and output variables. What does it mean? That for our model, for our LSTM model, we what we are doing actually, create input and output variables. So here, before creating input and output variables, we take one variable max length, maximum length. So that will be 100. So and step will be 1. So these will be the sent. We create empty list and name for the that empty list will be sentences, and we create another empty list and the name of that empty list will be next characters. So in sentences we take a sequence of 100 characters. Okay, and in next character um, we take the 101 character which should come. Okay, so like this we will train our model, and we so this is the process. So let's create data for these sentences and next characters. Let's run this. Now come the okay, this function def repeating def input output. So in this function, we will take raw text, then max len, and then step size, that is 1. So we will take our raw text, and then what we will do, we will create sequences, okay, and proceed one by one, okay. So for that, what we will use for loop, okay, for I in range 0 to uh, length of this length of raw text, okay, and like in the last, if 100 words are not, means 100 characters are not there, then this max len will not be satisfied, okay. So what we will do, whatever will be the length of this raw text, we will minus max len, okay. And then for this range function, what will be the step size, that is step only, that is 1, okay. Here 1 is there, okay. So this is our for loop. So what we will do, uh, for okay, sentences dot append raw text, and raw text for how much, I to, for example, for the first expression I value will be 0, so 0 to max len, I plus max len. Okay, sorry for the interruption. Okay, so next character. So here we are, 1 second. Okay, so sentence dot append raw text I plus, okay, it should be max len, okay. Then we have next character dot append, and then dot text, and then I plus max length. So like this we will. You may ask that here in sentence we are appending till I plus max length, and then in the next character we are appending I plus max length. So won't it will be the same word, or you can say same character? No, it will not, because in this indexing last number will not be included. So if it will be 100, so it will take from 0 to 99. Okay, so run this run this code. Okay, now we will run input output function and save the result in sentences and next characters. So run this function. Okay, now we will see how many input sequences are there. So number of sequences. So there are 5,61,525 sequences are there. Okay. So let's print some sentences to see how it's look like. Okay. So this you see, mm, like it is the first sentence of 100 words. Okay. And then come the next character. So here it should be mentioned I. So what will be the next character? It this O. Okay. So in the next input O will come. Then what should be the next character? N. So the in next equation sentence N will come. So the output will be space. So this is our data. We have sentences, and then what should be the next character? Okay. I hope till now it is clear. Then we have sequence length. So sequence length will be 100. We have created two empty lists. One is data X, and another is data Y. Okay, so sequence length is 100, and then we have data X and data Y, two empty lists. Now we will complete the function to convert the characters to integer using character to int. Okay, so we will create character to int function. Okay, what this function will do? Uh, this function will convert characters to integers. Okay, so it will append the integer version of the sequences to data x list, and append the integer version of next character to data y list. So before this, what we have created the sequence and next character list, it will just convert those to integer. Okay, so def character to int function, what it will take as input n characters, then sequence length, that would be 100, raw text, and character to int function. Okay, Okay. So here also we will loop using for I in a range 0 to n characters minus sequence sequence length, okay, comma, step size should be 1. Okay. So what it will do, it will go from 0 to n characters. Where are n characters? Here it is n characters. That is the length of raw text minus length, that is 100 or step size 1. Sequence n will be raw text and then I to I plus sequence length. Okay, it will be the input sequence, and sequence out will be the raw text, and it will be I plus sequence sequence length. Okay, so here uh, sequence in we have raw text I is equal to I to I plus इतना, and sequence out equal to raw text I to I plus sequence length. Then what we will do, data x dot append character to end, and then character for character in sequence n. Okay, it will be character to end. Sorry, okay, character to end. Okay, so it will append this, and then data y dot append character to end sequence out. Okay, so we will run this function. Okay, so I hope it is clear now. We are making for loop for I in range 0 to n characters. That is, I think, we have already calculated, and then sequence length to 1. Okay, so now we will use character to end function and then n characters, and it is sequence length, raw text, and character to end function, and save the output in data x and data y. So let's run this. Okay, it will take some time. Now after so how many patterns, input patterns are total now? It should be same as before. So total patterns length of data x 561525. Okay. Now these will be in integer form. So data x, you can see these are in integer form. Okay, and data y will also be in integer form. Now that we have prepared our training data, we need to transform it so that it is suitable for use with keras. So we have prepared our training data, but we need to convert transform it so that it will be suitable for keras. First, we must transform the list of input sequences into the form. We will transform these input sequences into the form samples, comma time steps, and then features. And this is the expected format by LSTM. So for this, we use the reshape. So x x equal to np dot reshape samples will be data x comma n patterns, total number of patterns. Here it is n patterns comma sequence length 100 comma feature that is 1. Okay, so run this. So this will be the output. Okay, so let's see the first value. Okay, so this will be the first value. Okay, now next we need to rescale the integers to the range 0 to 1. Okay, so we will rescale integers to between the range 0 to 1 to make patterns easier to learn by the LSTM network. Okay, that you and that LSTM network will use sigmoid activation function by default. Okay, so we will normalize our data. So for that, x divided by float of n vocab. Okay, so vocab is I think 62. We have calculated before. Okay, here it is 62. Yeah, n vocab. So we we will normalize our data. X, every value of x will be divided by the n vocab. Okay, so now see, so this will be the value. So for this value, this one value, we have divided n vocab, that is 62 unique earlier. So we have normalizes our data. Finally, we need to convert the output patterns, that is single characters converted to integers, into one hot encoding. Uh, This is so that we can configure the network to predict the probability of each of the 63 different characters. It should be 62, 62 different characters in the vocabulary and easier representation rather than trying to force it to predict precisely the next character. So if what we will do, we will do one hot encoding. So it will find the probability for all the 62 character, and from that we can decide what should be the next character. Each y value. Also, there is one more thing. If we don't do one hot encoding, uh, model may misinterpret it as a like regression problem in place of classification problem. So that is also the issue. So each y value is converted into a sparse vector with a length of 62, full full of zeros except with a 1 in column for the letter that patterns represent. Okay, so it will. I hope you know what is one hot encoding. Wherever a pattern will be letter will be there, one will come for X and zero will come. So for one hot encode the output variable, we use two categorical data y and then store it into y. Okay. So rows should be very high and columns should be 62 only. So you can see. Okay. So now let's print the y also. So this will be the shape. Now we will build our LSTM. Okay, so okay, now complete the function to build the LSTM model. So we will complete this. For this, for this, okay, so complete the function to build the LSTM model. So def build model. Okay, and now first of all we use model and then we use sequential. Okay, model equal to sequential. Then in this model we use LSTM layer. Okay, so model dot add and LSTM. How many neurons we should take? For now we will take 256 neurons. Okay, and then input shape. Input shape will be uh, x dot shape. shape, and in that shape we have rows, then column. So column will be the I think 100 approx. So we will take that only, comma. uh, okay, one will be the like rows, and then x dot shape, and then two. Those will be the column. Then we will add some dropout. We will add one dropout clear, and with a fraction of point 0.2, I think. Model dot dropout, and sorry, model dot add dropout, and then okay, point. Okay, and then we will return this model. Let's run this. Okay. So what we have done, we have defined a function build model. Then we created sequential one object model which has sequential model, and in that we use LSTM with 256 neurons. We give input shape x dot shape 1 and x dot shape 2, and we also add dropout layer. Okay, and in the last we add output layer, and for that output layer uh, we uh, we use softmax function here by default. Means soft Why we use softmax not sigmoid here, because if it will be it if it was a binary class problem, then we use sigmoid, but it is multi-class problem. We have 62 uh, um, I mean 62 classes, so we use softmax. So model dot add dance. Okay, and in that y dot shape 1, and activation will be soft max. Okay, one second, guys. Give me a minute. Okay, so now see, here we are. We have added. So what y dot shape will give? I will show you. One second. So y is the numpy array, and y dot shape will be the rows and column. So we have taken the out y dot shape 1, that is 62, and activation will be the softmax function. So I hope it is clear to you now. So let's run this. Okay. Now we will run this function build model and save in model. So for this, what we will do, for this warning, I think shape we need to pass as a separate layer. So what we will do? 1 second. From TensorFlow dot class dot layers, import input clear. Okay, and here in model we will not pass it under this. Okay, so we will add this layer model dot add, then input layer, and in this input layer we will provide the shape. So shape will be this only. Okay, and from here we will remove this argument, that is input shape. So in the latest version we have like this only in keras. So we have learned new things here. So run this, and then we will add input here. Okay, so run this, and now let's try. Great, it run now successfully. Now model.summary. So we can see the summary. This is our first layer, that is dropout. Okay, sorry, first layer LSTM layer, and output shape will be 256. Params will be 264, 264,192. Okay, and then we have a dropout layer. So output shape will be the same 256. And see, this dropout layer don't have any parameter. That is, it is because dropout layer is used to conquer overfitting. It is not used to do any type of learning, so it generally have zero params. Then we have dense one layer, which has output shape of 62. Okay, and these are the total parameters in that. So this is the summary of the model. And now come sixth question. Uh, so now we will compile the model. So okay, what are the hints? Use appropriate laws for multi-class classification problem with one hot encoded target variable. Use Adam as a optimizer. Okay, so model dot compile, and then in this compiler for loss we will use categorical cross entropy. Cate- Categorical cross entropy, and optimizer will be Adam. Okay, so this is the so we use loss as a categorical cross entropy as a loss, and optimizer will be the Adam. So run this, and now we will use this function, and then save it in the memory. Done now. Now what it is showing question 7, create a model checkpoint callback object. So we will create a checkpoint callback object. Okay, so once again. Okay, so use the following values for different parameters in model checkpoint class initiation. Use the following values for different for file path. We provide the file path for monitor loss. Save best only true. Mode min save weights only true. So we will save weights only. So file path will be the weights improvement and epoch loss and then hd.hdf5. Okay, so this is the format. Okay, so let's run this file path. Now we will create. Okay, so create. We will define this function create checkpoint, and we are providing file path as input. So checkpoint equal to model checkpoint, and in this we provide file path. Then we provide for monitor we provide loss, and then save uh, best only will be true, and mode will be min. Okay, so this will be the function for checkpoint. Run this. Okay, so now